I have 28 years of experience in IT, out of which I worked in USA for 9 years, worked for BFI sector, worked for American Express for a couple of years, worked for Progress Rail Services, worked for Indiana State Department of Health, where we developed a healthcare product. The domain knowledge that I have is BFSI and the healthcare and e-commerce application development and content development applications development. That is my domain knowledge. Initially, I started my career with the mainframes. After that, I switched to open technologies. I worked on various front-end technologies, various languages like Java, Python, Scala, C and C Sharp, PHP and Perl. And then back-end side, I worked on Oracle, Microsoft SQL Server, Sybase, DB2, MySQL. With this knowledge, I have been currently working on, big data technologies and distributed architectures. For last 11 years, I am into training and consulting, working as a coach, delivering the sessions for various corporates across the globe. I am a frequent visitor to APAC countries and USA for building a team of people in designing the data pipelines using this big data technology stack like big data and Hadoop components, Spark with various language APIs, Kafka with various language APIs, Cassandra, which is a NoSQL database, MongoDB is another NoSQL database, ELK, Elasticsearch, Logstash, and Kibana. And this is a search database, and Kibana is basically a presentation layer, which is a BI tool. NiFi, which is a data flow system, designing the data flows using NiFi, and Talent for big data, which is basically an ETL tool. And then Kafka is a data ingestion layer. Both batch ingestions as well as streaming ingestions it can do. So I am on TV for career development on Doordarshan. You see my programs frequently on Doordarshan on Saturdays and career development. I visited a lot of engineering colleges for delivering this technology stack to build a team of people and delivered a lot of sessions as a faculty development program as well. I published a lot of articles on cutting edge technologies and distributed architectures, which are published on the local newspapers. That is about me. So let us get started with the topic today. So welcome to this webinar on designing the data pipelines using distributed architectures, big data technologies. So I will talk about what are the technologies that you usually use in designing the data pipelines on the big data area. So for that, I will give you just overview of those systems, what they does, for what purpose that we're going to use those systems, and then we will see how they are used in different phases of your entire project life cycle. In order to implement your use cases when designing your data pipelines, how these technologies fit, where they will fit, and then what each system that you are doing that. We will take a BFI sector, banking sector use case, and then explain about the end-to-end flow, how they can be used in designing the data pipelines. So initially, when we talk about a big data technologies, and distributed architectures, what is the need for going with these big data technologies? First, we need to understand what is big data, right? Big data is the data, basically, which cannot be fit into the single physical server and which cannot be processed using the RAM and CPU cores, means the resources of a single physical server. That means if it is beyond the capability of a single physical server, to store the data and process the data, that data is called big data. Then what is the alternate? There are a lot of challenges that you face when you are dealing with the big data. What are the challenges? And then big data opportunities. When you do the analytics on big data, what are the opportunities? And then how you can make a difference when compared to the other companies. When you implement these big data analytics on your data, whatever the domain it is, It can be a healthcare, it can be a financial data, it can be e-commerce application data, banking and banking data, or okay, telecommunications data, okay, or automobile data, any data. Okay, so what are the opportunities? And then okay, Hadoop and other distributed architectures as a solution to this big data. Okay, so and then how they will work, how these big data technologies will work, and then what are the added advantages of these big data technologies, distributed architectures, when compared to the traditional technologies which are based on a single physical server. We're gonna just I will give you an overview because of the time constraints, only 1 hour. Okay, so I will stop the session 5 minutes before 4, so that you can put your questions on the chat box so that I can answer your questions. Okay, so advantages of this big data, and then business benefits, okay, and of this big data, and advantages, business benefits of these big data technologies, and then the Hadoop different kinds of ecosystem on a big data environment, what system will do what, and then what are the NoSQL systems available which are widely used right now in the industry in designing the data pipelines. Okay, and data ingestion tools overview. What are the highly scalable data ingestion tools? Okay, okay, what are the data ingestion tools available? Okay, highly scalable data ingestion tools available, so that we can get the enough data to do a big data processing by a distributed parallel processing engines. And then finally we'll see some use cases related to okay, BFI sector, how you design the data pipelines. Okay, batch ingestion, how you design the batch data ingestion layer, and how you design a streaming data analytics that you do. Okay, how you design your systems. Okay, we are gonna talk about that. Okay, so when we talk about a big data, how it is getting generated from various sources, because of the technology enhancements, large volume of the data is getting generated from various sources, like they can be your smartphones, smart watches, smart appliances, self-driving cars. Okay, and Internet of Things is the main source from which you are getting large volume of the data. By 2025 there will be 222 billion IoT devices, roughly 6 things per online per person, causing huge amount of the data getting generated. And then other the sources from where okay, the large volume of the data, among us amount of the data is getting generated is social networking sites. It can be Facebook, Google, Netflix, YouTube, okay, and then Amazon Echo, okay, and then WhatsApp. So these are all the various sources. Very large volume of the data is getting generated in 1 second. In 1 minute, this much of data is getting generated from the just social networking sites. Okay, you can imagine from various domains how much big data is getting generated because of the technology enhancements. Why we are generating this data? With an intention to analyze it, to understand the customer based on the domain that I are working, so that I can provide a required products and services, so that I can make a difference, and then I will be the competitor in the market, and then the customer will be stay connected with us, so that okay, we'll run into profits. That is the main focus, right? So what are the other domains from where the large volume of the data is getting generated? Telecom industry, insurance sector, government sector, finance and banking, healthcare industry, automobile, education, retail. So once you collect the data from all these sources, you know what kind of analytics that I have to do on my data to improve my business, to make a difference between the other competitors in the market. What kind of analysis that I do, based on that I can develop some kind of new products and services, so which will attract that customer, so that customer will stay connected with us, so that we'll run into profits. Okay, for those things we are going to use okay, the we are going to use this data, which is among us amount of the data which is collected from various sources, with an intention to analyze it, to get the business benefits of the data analytics. Okay, so now what are the challenges when the data becomes so big? When the volume increases, okay, so your, okay, what is going to happen? Okay, your single physical server and the technologies which are based on the single physical server, like your Java framework or a .NET framework or MySQL database or any other RDBMS databases which are designed to run a single physical server and then use the resources of a single physical server. Okay, so they cannot fit in the data into that single physical server using the hardware of that particular server, and then RAM and CPU core that particular server. So then, okay, there is a problem. You cannot process big data, you cannot store big data. That is a challenge. Velocity, the rate at which the data is flowing your systems, and that means my system should be capable of handling various kinds of workloads. Okay, at the peak hours I will be getting more and more transactions. My system should be scalable enough to handle that much of bigger data in terms of storage and processing. If I cannot, okay, unpredictable behavior, the system behavior you have to face. So that means, okay, so the performance is affected, or sometimes your system may crash. Okay, variety of the data to handle, okay, the data which is stored in the form of structured, semi-structured and unstructured, okay, data. Unstructured needs large number of resources in order to get it processed. Okay, so if you don't have those many number of resources, your system will not work. So veracity, okay, and then value of the data. Veracity, in order to find out an accuracy of the data and value of the data, you have to, okay, have a big data handling systems. Okay, so why you have to collect the data? Okay, what is the need for collecting very bigger data? I wanted to do the analytics on the data. When I do the analytics on very bigger data, okay, so I will get the correct analytical results. So say banking industry, right? So when a customer approaches a bank and okay, he wanted to, okay, provide the loan for him, okay, or credit card for him. How I can decide about the credit card limit? How I can decide, okay, and then whether I can provide the credit card to him, or whether I can provide a loan to him, and then what is the maximum loan amount that I can grant? How I can analyze it? Okay, so based on the previous customers of the same pattern, okay, I will run some machine learning algorithms on my data. My algorithms will be trained on the data, on the existing data which is generated from various customers of my bank, and then based on that I will decide about the amount that need to be granted, and then also decide yes or no whether I can give the loan to this person or not. So for that purposes, I'm just mentioning one use case in the banking industry. So based on the domain that you are working, you know what to do with your data, what kind of analytics that you wanted to do on your data, so that okay, you make a difference when compared to the other competitors in the market. Okay, so when you do the analytics, what is the advantages? Cost reduction. You can develop a new products and services which fascinate the customer and attract the customer so that he will stay connected with you. Okay, and then okay, those decisions so that you are providing when you are developing an e-commerce application, you can provide a better support for them, and then okay, your algorithms run faster on a big data. Okay, if you can provide a big data technologies, okay, they will be faster, and then so that okay, the customer can take a better decision making whether they can buy a product or not. Okay, so that those are the high level advantages of doing the analytics. Okay, for that, okay, the problems which is faced when the data becomes too big. When the storage is exponentially growing, your traditional technologies which are based on a single physical server cannot handle that data anymore. Processing complex data, it requires large number of resources, processing related resources like RAM and CPU cores, and then your single physical server cannot have even those many number of resources, even though you pour millions of dollars. That's why there is a need for distributed architectures. Okay, so and then processing data faster is also a big problem when the data becomes so big. So now what is the solution for this big data? The Hadoop is one of the technology, one of the distributed architectures, and then lot of other distributed architectures like they can be a data ingestion tools, distributed parallel processing engines like Spark, or okay, distributed RDBMS databases or distributed NoSQL databases like Cassandra, MongoDB, CouchDB, MarkLogic. Okay, so Amazon DynamoDB, Redis, all these databases are okay built on top of a multi-node cluster environment. That means what you mean by multi-node cluster environment. Okay, so you will build a clusters of a with multiple machines. Each machine will have its own hardware related resources and processing related resources like RAM and CPU cores. Okay, so when you build a cluster, so okay, you when you are building a cluster, you connect all these machines together in a LAN network. Okay, in a LAN network, so that they can be communicated with each other and share the load in terms of storage and processing, so that they should be able to store the data in a big way, process the data in a big way using the okay storage, RAM and CPU cores of multiple servers. That means there is no limitation. You can keep on increasing the number of nodes, that means number of servers to the existing cluster when the load increases in terms of storage and processing. That means okay, they are highly scalable, available and reliable, and then very faster. Why? Because your data is divided into chunks in these distributed architectures and then spread across multiple servers. That's why they should be able to okay store the data in a okay in a big way, so that and then you can process the data in a big way. Okay, so you using these distributed architectures. And then okay, so what I am telling you on one framework, so that all the framework is the same concept, but maybe architecture might be different, but they work in the same model. Okay, all the distributed work is in the work in the same model, so provide the very faster environment, highly scalable environment, available and reliable environment, so that the your system downtime is very less. Okay, or no downtime when you configure these big data systems correctly. Okay, so when I talk about one system, you can apply this knowledge to other systems, all the distributed architectures where they use multiple node cluster environment. Okay, Hadoop is one of the technologies. All these distributed architectures come with an open source software. Okay, they are available for open source Apache. So what is the advantage of open source softwares? So you can get the software as well as binaries also. When you get the binaries, you can use that software for your business purposes without paying a single license cost. Okay, there's no license cost. Okay, and okay, open source. And then you will get the source code also, so that you can develop okay new products and services from the existing frameworks. So that's the advantage of open source, right? Hadoop is like, and then all other distributed architectures are available at open source Apache. Okay, the Hadoop is an open source software framework for storage and processing of data on clusters of commodity hardware. For that, it has a distributed storage in which how it happens when you copy a file into this cluster, which is formed with a multi-node environment. Okay, so it will divide that file into chunks and then spread across. Some chunks of that file is stored in first server, second chunks, some chunks in the second server, some chunks in the third server, so that okay, your data, one file data is stored in more than one server in the form of chunks, so that okay, when you write a program, okay, using some kind of a distributed parallel processing frameworks like MapReduce and Spark, it will that framework is designed to send that code to all the nodes where the data blocks of this file, which is being processed or analyzed. Okay, it will go there to all the nodes where the data blocks are available, parallelly process using the RAM and CPU cores of all these servers. That's why you don't need to wait for the resources, because okay, so you have n number of machines. You use RAM and CPU cores of multiple servers. You are not overloading any single physical server. So that's why you don't need to wait. And then you are processing small chunks of the data using your code, and then processing small chunks of the data is very faster than processing a bigger file. That is the winning factor of your distributed architectures. Okay, okay, that means they are 100 to 1000 times faster than traditional technologies which are based on a single physical server. Okay, so the big companies are designing their data pipelines using these big data technologies, big data technology stacks. Okay, so how the data will be distributed like this. Okay, so your data is divided into chunks and stored across multiple servers. Okay, so that in the form of blocks, each block is replicated 3 times into 3 different servers, so that one copy is dead on which is stored on the dead machine, and then you have another copy, you are not losing the data. And then, okay, you are not losing the data. For that, it is putting the multiple replications of each of the blocks, because you are storing the data in a distributed fashion, okay, in the form of small chunks. Okay, when you write a program using Spark is very famous, a distributed parallel processing engine. Okay, very famous. Okay, so and then MapReduce as well, but it is old. Okay, Spark is the latest one. Provides parallel processing of data present in HDFS, allows data to be processed locally on each node, making use of its resources. So, okay, your code goes to all the nodes where the data is available, and then process them parallelly. Okay, using the resources of all the servers. So here, if you Java framework is taking 4 hours, because it is taking the resources RAM and CPU cores and storage of a single physical server. Here my Spark is okay okay, implementing a distributed parallel processing engine by sending the code to all the nodes in the form of blocks and then processing parallelly. That's why instead of 4 hours, it is completed in 1 hour. So if it is 4 chunks, that is the way. If you have thousands of chunks, okay, that's why I said, okay, so the distributed parallel processing engines are 100 to 1000 times faster than your traditional technologies which are based on, okay, single physical server. So, okay, so the modern next generation data processing and management. So how they will work from your enterprise applications, multiple applications, like enterprises, social media, activity generated data, public data, archives, or other resources. You are sending the data, putting the data in the big data systems and big data storage, where it is built with a thousands of node cluster environment. And then, okay, from that, so from the lot of data archives, through using lot of data ingestion tools, you are ingesting the data into these Hadoop systems. And then some of the structured data we are going to use store it in the a distributed RDBMS databases and NoSQL systems here. Okay, you can bring the data into HDFS and send the data to these systems. And then once you analyze the data using MapReduce or Spark, in the middle layer, a big data layer, and then other systems can take the data. Other systems, transactional systems can take the data, or other operational data stores can take the data, or okay, your distributed RDBMS databases or NoSQL systems or OLAP systems can take the data from here, this big data layer. So this is how an enterprise applications are using this big data layer. Okay, these are the high level picture. We are going into the details of a BFI sector data, how you design the data pipelines using these big data technologies stack, that we are just having a brief description about each of these systems and how they will work, for what purpose that you are going to use these systems. Okay, and then when you are using these big data technologies, okay, so because they are built of using multi-node cluster environment, you can utilize the RAM and CPU cores of storage of all those servers. Okay, and then they have a replication of the data. Even though one server is dead, whatever the data which is stored on that, okay, what is the data which is getting processed on that, will be automatically switched to the other available live nodes. So that's why there is no data loss, or no, your programs will continuously up and running without any failure. That's why no downtime. That's why these systems, okay, when the load increases in terms of storage and processing, you can keep on horizontally, keep on adding one more node, one more node, one more node to the existing cluster, so that it can handle very, very bigger data based on your requirements. You can increase the, okay, you can scale up the cluster or scale down the cluster. Okay, so based on the available, based on the load that you are putting on the clusters. Okay, so and then what are the advantages of this big data technology stack? Scalability, availability, okay, and then reliability, and they are cost effective because you are using open source softwares, and okay, and then commodity hardware, very cheaper. Okay, they are flexible to handle any type of the data, structured data, semi-structured data, and unstructured data. And then they are very, very faster because they are implementing a distributed storage and a distributed parallel processing. That's why they are very, very faster. They have an automatic failover mechanism. That's why you never see Google is down, Facebook is down. Why? Because they are using these big data technology stacks. They are 100% available and reliable. They have their own auto failover mechanism. Okay, so applications of big data. Okay, using this big data, what are the applications that are built on this big data area? What are the domains? So it can be healthcare or a retail industry. Okay, stock exchange. You can do the analytics on your stock data so that okay, you can get the result based on that. You can spend the money or not. You understand that but stock well, so that you can do you can do a wise investments, okay, on the data analytics results. Okay, it is say you can develop a security surveillance systems. Okay, like your over and all, how it is giving you the recommendation based on that large volume of the data is getting generated and processed internally. Based on that, it will give you the alternative routes and all, right? So these are all the different kinds of applications which are built on the big data technologies and clusters in on clusters environment. Okay, okay, so the big companies who are using these big data technology stack like AOL, eBay, IBM, Adobe, Twitter, Amazon, Facebook, LinkedIn, Yahoo, all these companies, okay, are started using from 2006 onwards. What are the technology stack available on this? Okay, what are the different systems, where they come into picture? What are the things that you require in order to do your business processing? Okay, so what technology does what? Here we see in this big picture, you see lot of technology stack here. Okay, some of them are distributed parallel processing engines, some of them are machine learning algorithms implementation framework on a very, very bigger data, some of them are okay graphical algorithms implementation framework on very, very bigger data, some of the okay highly scalable and reliable search engines. Okay, very faster search engines are available like Solar and then Elasticsearch, and then there are batch automation systems like Uji and Airflows. Okay, these are the systems, and cluster management systems like Zookeeper, and cluster resource management tools like Yarn. Okay, a distributed storage like HDFS, distributed data ingestion tools. Why I am talking about distributed means they are very faster, whether it is a data ingestion tool or a okay distributed parallel processing model or a distributed storage. They are very, very faster when compared to the traditional technologies which are based on a single physical server. Flume tool and Scoop tool, and then Kafka. These are all the different kinds of data ingestion tools. Okay, they can provide the data at a very, very larger scale to your Spark engine, which is a distributed high, okay, very large. It can process very, very large volume of the data. Okay, Spark. Okay, Spark can do, we can handle various workloads like it can run machine learning algorithms on very, very bigger data, graphical algorithms on very, very bigger data, and then it can do structured data processing on very, very bigger data, and then unstructured data processing on very, very bigger data, and then can live data processing also on very, very bigger data. Live data processing means streaming, continuously coming data, unbounded data. So it has a different kinds of modules available there in the Spark distributed parallel processing engine. In the same way, in this Hadoop framework, you will have Hive, Drill, and Impala, which are okay a distributed RDBMS databases which are designed to run on multi-node cluster environments so that they can utilize RAM and CPU core and storage of multiple servers so that they can process very, very bigger structured data. Okay, so like that, so lot of systems are there. Okay, some of them are NoSQL systems are there. Okay, which are like HBase, okay, MongoDB and Cassandra. These are very widely used NoSQL databases. So Facebook uses HBase for storing their user messages. Okay, enormous amount of billions of transactions per day it can handle. Okay, a transaction processing per day, billions of transactions it can handle. Okay, because of their architectures. and then because of the okay unlimited number of resources on a big data clusters. Okay, so these are the different technology stacks. Like I said, some of them are data ingestion tools, some of them are distributed storage systems, some of them are distributed resource management systems, some of them are batch automation systems like your cron tab or okay cron tab okay is used for automating your batch flows, right? You can schedule the batch flows to run at a particular regular intervals, right? For that, for implementing that on a big data technology stack, you have some of the ecosystem components available called okay UG and Airflow, etc. Okay, some of the live data processing like Storm, Kafka comes with a live data processing module called Kafka Streaming. Storm is a live data designed to handle streaming workloads, and Spark has a module called Spark Streaming. So that means you can do live data processing on very bigger data also. So all these systems work together to solve your business problems. Where to fit what for my particular business use case. So that is what the design okay done by the architects. Okay, what are the business capabilities, what kind of workloads that I want, whether IO intensive workloads or okay or CPU intensive workloads. Okay, so based on that, what system helps in doing so? Okay, to handle my business workloads. Based on that, okay, I will okay put a particular system in this data ingestion load. I wanted to go with Kafka for this workload, or otherwise I wanted to go with Flume. For that, I need to know what are the capabilities of Flume, what are the capabilities of Scoop, what it can do as a data ingestion tool, what Kafka can do, what is its capabilities, what is its scalability, what is its okay speed, and then throughputs, how much throughputs of the data it can give to my big data system so that they can handle very big data in terms of storage and processing. Okay, so based on that, they design the data pipelines. So we will see on the BFI sector, okay, how the data pipelines are designed, okay, in a little while. Okay, so these are all the a big data technology stack. Okay, so that you are going to use to solve your real-time business problems. Okay, so some big data use cases in the business. For what purposes that you are going to use the analytics on your big data? So log analysis to stop the potential failures of your cars. Okay, self-driving cars, they are generating very large volume of the log data. By analyzing the log data, you can okay apply the online patches to the software so that it will run. Okay, so that means you are stopping the potential failures of that okay self-driving cars. Okay, or IoT devices, you can bug fixes of IoT devices by analyzing the data which is generated by IoT devices, and they stop the potential failures of IoT devices by analyzing the log information of your database servers, web servers, and okay operating system servers. Okay, so you can stop the potential failures of those systems. For that, you are bringing the data at a regular intervals and then analyzing the data using the big data systems. Based on that, okay, you develop some kind of alert system so that okay this system is going to fail, so that I will go and then fix that issue before it is actually getting failed. That's why you can stop the potential failures by doing the log analysis of various okay various systems. So e-commerce application personalization, developing recommendation engines, okay, use by running the machine learning algorithms on a very bigger data environments. Okay, and then automate candidate placement in recruiting, and then insurance fraud detection. Okay, do the risk analysis on your financial data by using your financial data in the banking sector, so that I can decide about giving a loan or like or when we are providing a credit card to the customers. Based on their repaying capabilities, I can set up the limits to them, also based on the analytics coming from my system. Okay, so relevancy and retention boost of for online publishing, 360 degrees view of the customer, developing security intelligence systems, and then price optimization of your product in an e-commerce applications, and social media analysis and responses, and do the sentiment analysis on social media data, which belongs to various domains, like it can be sports or it can be politics, it can be okay about the some kind of electronics, some goods, Okay, so you can do the sentiment analysis on the data, and then based on that, you take the business decisions from there by analyzing the social media data, preventive maintenance support. These are some of the use cases that I mentioned here. There are hundreds of use cases where you use these big data analytics outputs to improve your business. Okay. Okay, when we talked about distributed parallel processing engines using some distributed framework like Spark or MapReduce or any other distributed parallel processing engine. Some of the NoSQL databases are designed to run on, okay, multi-node cluster environment like your MongoDB. You might have heard about MongoDB and Cassandra and then HBase, which are very widely used in the industry now for dealing with transaction processing as well as data analytics on very bigger data, because on RDBMS databases are designed to work on a single physical server. When you cannot scale up to thousands and hundreds and thousands of nodes when you are working on an RDBMS databases like Oracle, MySQL, Microsoft SQL Server, and PostgreSQL. These are all the traditional RDBMS databases, right? You have a distributed RDBMS databases, but there is a limitation because of the joins. Large volume of the data is getting moved across the cluster of machines, then it will degrade the performance of systems. That's why the RDBMS databases are not highly scalable. Okay, there is a limitation. That's why there is need for creating a NoSQL systems. Okay, NoSQL means not only SQL, or it is not a SQL. Okay, non-relational SQL. That means these NoSQL databases are designed to, okay, run on a big data environment, and they provide very faster environment when compared to RDBMS databases. So NoSQL databases are schema agnostic. That means you don't need to define the upfront schema. They are designed to work with auto sorting automatically. Data will be related data will be ending up going into one node, so that when you hit one node, your query retrieves a required information. You don't need to search for the multiple nodes, okay, to get the required information for your query. Okay, so it will be all the related information is stored in one place. That is called auto sorting. You don't need to do explicitly partitioning. You don't need to apply a partitioning concept like you do for RDBMS databases like Oracle. Okay, and then their okay, automatic elasticity they have, highly distributable, so that keep on adding one more node to the existing cluster, so that it can handle enormous amount of the data in terms of storage and processing. And then they are easily scalable. Okay, they have an integrated cache mechanism. Using that cache, they make the queries very faster. Famous NoSQL databases are, okay, HBase. One of the famous NoSQL databases is HBase, MongoDB, and Cassandra. Okay. Okay, so the HBase architecture side, right? So you'll have HBase is built on top of Hadoop. It is tightly integrated with Hadoop framework. It can work with your Spark or any other databases which are available with in Hadoop framework. So you can do the Hive and HBase integrations. Your Spark engine can read the data from HBase. HBase is built with a multi-node cluster environment. Okay, so because it stores the data in the memstore memory first, and then once that memory is full, allocated memory is full, it will store the data in the disk. Okay, your queries go and directly get the data from the memstore, because when you are reading the data from the memory, it is very faster than reading the data from the disk. That is how all the NoSQL databases are designed to have an integrated cache, store the data in the memory as much as possible. They are having a different kind of performance improvement techniques to, okay, improve the performance of your queries, so that they are very faster. Okay, so that is what about the HBase. Okay, and then Cassandra database. Cassandra has a very better communications among the cluster of machines. Okay, so Apache architecture, so it will have a lot of internal protocols like gossip protocol, which will be used to make the communications between the node. When any node is failure, that gossip through gossip protocols, other nodes will come to know, so that okay, so that it will automatically do the internal automatic disaster recovery mechanism of your data, so that your queries like read request and write request be served in a very lightning fast way. Okay, because of this gossip protocol. And then instead of and then and then it has an integrated cache mechanism, and okay, so because of the cache mechanism, and then the mem tables, it is having the concept of mem tables, and automatic sharding mechanism. Okay, so it is very faster in serving your requests. Okay, so that is how Apache Cassandra works. And then okay, so MongoDB, another very beautiful okay NoSQL databases which uses JSON structures in order to store the data. So you can have a nested JSONs. In each nested JSON you can have nested arrays of elements, and then it has a beautiful query language like your SQL language, how you built in your logic based on your conditions. And so you can apply filter operations, group by operations, aggregation operations, and sorting operations on your data on RDBMS where you use in SQL, right? Whatever that SQL can do, okay, the beautiful language provided by the MongoDB, okay, you should be able to get all those kind of business implementations on very bigger data. That is the what I am emphasizing more on bigger data. So these are designed to work on multi-node cluster environment. Your queries will be faster, okay, very faster, because they are implementing the distributed parallel processing, automatic failover mechanism. That's why they are providing 100% availability and reliability, like we discussed before on a Hadoop. Those features will be okay available with MongoDB also. Okay, all those kind of advantages comes to MongoDB also. Okay, so it stores the data, JSON data model with the dynamic schema. It can be integrated with Hadoop, MongoDB, and community support drivers are available to, so that okay, you can connect through Java program or a Python program, or a Spark program using the MongoDB connectors. From Spark you can connect to MongoDB and transform the MongoDB data. You can insert, update, and delete, and then okay, you can do all the manipulations using the okay a distributed parallel processing engine by taking the data from MongoDB. So it is also like your Cassandra and HBase. It is also comes with an auto sharding mechanism, and then they, because they are and then they are horizontally scalable. You can keep on adding one more node existing cluster, okay, so that it can handle okay very enormous amount of bigger data. It is highly consistent when compared to the other NoSQL database. That's why it is used for building a shopping cart applications and e-commerce applications. Okay, so but your e-commerce applications can handle very bigger data, because MongoDB is designed to run on a multi-node cluster environment. So it has a lot of aggregation frameworks to implement the aggregations in a very faster way. It has a rich secondary indexing mechanism, okay, including geospatial and then time to live features. How long you can define your data, and then define about how long it can stay, so that it automatically it has a features to remove the data without explicitly deleting the data. You can define a retention period for your data. Okay, so that after that retention period it is, your data will be related. Using all these features on this big data architecture, you should be able to analyze very bigger data. Okay, Kafka okay is a highly scalable a data ingestion tool, and a streaming platform which is used for okay ingesting the data from a sources to a destinations using a publisher and subscriber model. Okay, so producers are applications which are providing the data to the okay receivers, put that in the Kafka broker, so that applications who wanted the data can read the data from Kafka. So it will provide Kafka will provide very fast environment. It's built with a multi-node cluster environment. That's why it helps the producers and consumers to write faster and read faster from the Kafka brokers. Okay, so Zookeeper is one of the component of this Kafka environment. Okay, it uses Zookeeper for storing the metadata information, which is used for implementing the failover mechanism. Okay, and so this Kafka is mainly highly scalable data ingestion tool when compared to the other data ingestion tools available in the market, like Flume or Scoop, which are also distributed okay data ingestion tools. But we can compare the features of this Kafka with that. Okay, and then a lot of other tools like IBM MQ, and then ActiveMQ, RabbitMQ, lot of tools are there. You cannot compare the scalability, availability, reliability, and speed of the Kafka ingestion tool okay, with the other data ingestion tool that I just mentioned. Okay, so this Kafka is designed in the data pipelines in a big data industries like in enterprises where they deal with the big data. Kafka is your one of the component in designing your data pipelines. Okay, so because it is highly scalable, available, and very faster, and then high throughputs also in a very faster way. It can ingest the data from sources to the destination. That's why Kafka is one of the layer in designing your data pipelines. Okay, so this is credit card processing in a BFI sector. Okay, an end-to-end flow. What system will come in what place? Say when you swipe a card, okay, from a credit card, a web application will take it. From there, it will write the data using a producer application. It will write the data into the Kafka. From Kafka, okay, you are using, okay, Spark streaming engine. Okay, the data is coming as a streams. This is because credit card processing is a continuous happening round the clock, right? In various countries. So you take Visa, Master, they will be running on round the clock because the Visa and Mastercard. Okay, credit cards are used by worldwide, right? So that means round the clock that transactions are happening. That's why it comes as a streaming data. The Spark streaming module will take it, and then HR, it is this is all adjusting NRT status. These are all the financial industry terminology. Okay, so for adjusting the adjacent NRT status and write the data into HBase memory. HBase that we talked about, it is a NoSQL database, highly scalable, okay, transactional database or analytics database. You can use it for analytics, the data which is stored on the HBase, or we can use it as a transactional processing database. So from other systems also the HBase is getting loaded, and then okay, so from Kafka through some other process called okay, a Flume system. Okay, Spark systems are the data is getting loaded into HDFS. Okay, and then from this HDFS, which is a distributed storage, the data which is stored in the form of chunks, and then Hive, MR, Spark, and search engines can access the data from this and then use for various purposes like automated and manual processing, and then analytical adjustments and pattern detection can be done. These kind of analytics can be done using these systems on the data which is stored on this HDFS. So from HBase memory, automated manual, and then review of NRT changes and counters, those kind of algorithms can be run on this HBase memory data using various technologies. So this is how you design the data pipelines on a okay on a credit card processing or any other okay industry. Okay, so you can take your use cases, you design your data pipeline, where Kafka go, where Spark can go, because what kind of workload that I am doing, what are the capability of that particular system, what Kafka can do, what the Spark can do, what HBase can do. You need to know about all these systems so that what will fit what place, you decide and then use it. Okay, so the next thing is like completely designing the data pipelines in a banking industry. So in a typical bank industry, okay, how they do the batch ingestions and then how they do a streaming workloads. So system of record means where the data is getting generated. So the data can be generated in the banking industry because it has various applications like banking applications, credit card applications, insurance applications, community banking related applications. They will have a lot of applications. Each source data, okay, you are going to collect in a big data system like this. It can be from relational databases like Oracle and MySQL. They are getting the data, and then system of record means one more source is they are getting the data from Teradata, and then some of the legacy systems are putting the data in the Dropbox from the Dropbox through FTP tools. Okay, so the data is getting transferred to a big data systems like HDFS or okay using the ETL tools like Ab Initio or Informatica. Okay, they are ingesting the data into HDFS by integrating them. Some of the okay data will be okay ingested because using a structured data ingestion tool like Scoop, okay, from the relational databases from Scoop, okay, using the Scoop tool, which is a highly scalable structured data ingestion tool. It can work with Hadoop systems, okay, and an external RDBMS or NoSQL systems. That is also can be used from getting the data. They are using relational databases here using Ab Initio. They are bringing the Teradata to data and then putting in HDFS. From there, the data is loaded into Hive tables with an intention to analyze it using SQL. Okay, and then from this, using the Spark load, Spark is reading the data from HDFS, and then directly using the Cassandra connector, they are loading the data into the Cassandra, the data which is received from various sources like system of records, like relational databases and Teradata and Drive access. Finally, your destination is Cassandra. In between, you are using some kind of intermediate storage layers, and then use large a large volume of data processing systems like Spark to process the data, and then do the analytics, query analytics that you do using the queries. Spark analytics using some kind of programming languages, you do the analytics using Spark and write the results into Cassandra. From there, microservice APIs, and then digital teams are taking the data from there, or operational use cases, or your BI tools like a lot of ClickView or Tableau. Those tools can access the data from Cassandra, for um, um, representing the data in the front end layer, generating pie chart, bars, or histograms and all. And then data grids, and then so that the end user can utilize the data for business improvements. So this is consumption layer. Cassandra is a consumption. So one more batch ingestion layer the financial industry made use is logs, generating the logs by the systems, analyze it to stop the potential failures of those systems. They use the Flume tool to ingest the data into HDFS. From there, they are loading the data into Hive. They are doing the query analytics, and then some of them, the data can be analyzed using the Spark. And the unstructured data like that. So, and then store the data into the Cassandra, and then from the Hive also, they are sending the data Elasticsearch. So they are for doing the search capabilities on very, very bigger data, because Elasticsearch is a NoSQL database, which is mainly used, it comes with a distributed architecture, and then a search tool, a search database. Using the Lucene search engines, you should be able to search the data from the Elasticsearch database in a very, very faster day. And then Elasticsearch is tightly integrated with a BI tool called Kibana, which is used for reporting purposes by reading the data from Elasticsearch. So batch ingestion layer data can be used, different use cases. So relational database, Teradata, Dropbox, here log generator, they are using Flume. So because this will be based on what kind of workload that you are using, they use a different systems in a different phases of your project life cycle. So and then batch ingestion can be log generator from Flume, Hive, and then from Hive, some of the data, query analytics data, with doing the integration with Hive, Hive, and then HBase integration. So you are putting the data into the HBase also. So Hive is a batch processing system. HBase is a a real-time processing system and transactional processing system. It can do the OLTP, and then it is an OLAP. We can integrate the data between these two, so that Hive will get a live data from HBase, and vice versa. And then Hive data is sent to the Elasticsearch, which is used by the Kibana for reporting purposes. Cassandra data they are using for reading the data from Cassandra through various microservices. Microservices are built for specific purposes, right? So they will be running, and then getting the data from this consumption layer. Consumption layer is Cassandra here. Real-time streaming systems. So system of records, Kafka producer, and then from cloud through microservices. Using the Kafka producers, you are they have AWS cloud or Azure cloud from that cloud environment. By writing the Kafka producer code, they are ingesting the data into the Kafka. From there, so your Spark or some other program is acting as a consumer, which is reading the data from Kafka, putting in HDFS. From there, you are loading that structured data into Hive, and then use the analytics. Use the Hive for doing the analytics using SQL engine. So Hive comes with a query language called Hive query language, using which you should be able to analyze the data using SQL, and then store the results into a HDFS file system again with the results of your Hive QL queries, or you can store into some kind of intermediate tables. From there, a reporting tools can read directly data from Hive also. Okay, and then another real-time ingestion tools are like Kafka producer, Kafka. Okay, from there, okay, HDFS is reading that. So we are putting the data in HDFS through some kind of other internal data ingestion tool, from reading the data from HDFS, putting into HBase also, so that your business layer can use Hive data sometimes or HBase data sometimes. Okay, so all the data is all KMS, and encryption and description will be done while transferring the data over the network. That means your data is secured. Lot of a security feature like Kerberos security, TLS security, or KMS security can be implemented in various stages and various systems in order to safeguard your data. Okay, so system of records, Kafka, HDFS, Hive, and HBase integrations, and okay, so your Hadoop systems also can make use of this data. Okay, real-time data ingestions, Kafka producers bringing the data, okay, into the Kafka, writing the data into the Kafka. From there, HDFS, from there Hive, and HBase will get the data. So they are reading through microservices also. Okay, and then from this Hive, okay, one more use case, they are using this data from a Hive, which is analyzed through Hive into the Teradata, which is used for business, generating the business reports by querying the data from Teradata, which is a distributed database. Okay, query an external distributed enterprise data warehouse. Okay, query analytics, fast read on business. Okay, a driven model here on Teradata. Okay, so you can use Teradata data for for generating the reports by some kind of BA tools like Tableau or ClickView or any other tools. Okay, so this is Hive and HBase integration. Okay, so you can do that, sync the data. So we talked about the same use cases for batch processing. It is a real-time processing data. Okay, the real-time processing means continuously coming data using a Confluent Kafka, Confluent an enterprise edition of Kafka, using which you should be able to get lot of features. Okay, through connectors or through a custom written producer, you should be able to, okay, ingest the streaming data, continuously coming data. Okay, and then you do the stream analytics using Spark streaming, some middle layer using Kafka also. Kafka has a module called Kafka streaming. You can do some kind of intermediate level streaming, stream processing here, and then final stream processing you can do using Spark streaming features, and then store the results into Teradata or HBase, or from there a microservices can read the data from there. Okay, so this is also same thing, some more systems are added. Okay, so I am done with from my side, and then it is a time for questions. If you have any questions, we can answer the question. You can post the questions in the chat box so that I can answer your questions if you have any questions. Time is less, I had to rush to complete this data pipelines in order to, because some people will be knowing those systems when I'm talking about that are not, I don't know. That's why I had to give some kind of overview of all the systems that are widely used in designing the data pipelines. Difference between Parquet and Avro ORC file, difference between control M batch scheduling and UG orchestration. Very good, a good questions. Okay, so what is the difference between a Parquet file? These are the high performance file formats. When you read the data using Spark Engine, a JSON file or a CSV or TSV file, okay, so it is, when reading the Parquet files, when compared to those files, when reading Parquet file and Avro file and ORC files, it is 10 times faster, because they are designed to give you the random access, because they store the data in the form of row column oriented file formats. Okay, Parquet file and ORC file. Avro file is designed by Dow Cutting, okay, which is uses JSON structures internally, which is optimized for querying the data from Avro files. Okay, so these are Parquet files and ORC files are, okay, almost similar. They store the data in the form of key value pairs, which are very, very good in reading from the Hive data warehouse queries or using the Spark engines. Okay, Avro is a generic file format, okay, which is using internally JSON structures, which is created by Dow Cutting on big data systems. So they give you very optimal performance. Difference between control M and batch processing and WUGI. WUGI is especially designed for a big data environment, and then Airflow is also, which is designed for very, very bigger data. I mean, it's a lot of features for designing your complex batch flows to schedule to run. And then control M is kind of is from IBM. Control M tool, control M is from IBM. Okay, it is not as scalable and flexible to work with the distributed systems. Okay, like WUGI and Airflow. Okay, so it is an enterprise tool. Again, there is an advantage. Well, WUGI is open source, and then control M is a licensed tool. That is also one of the difference. Okay, so it can, online streaming can be structured data or semi-structured data. Okay, using the a module in Spark called structured streaming module. Okay, you can treat unstructured data as a structured, and you can treat it as a structured and then process it. Okay, using the transformations and actions provided by the Spark streaming module. Okay, yes. Okay, I will share it to Skill Up, right, and then they will share it across. Okay, okay. Thanks, Veer. Yeah, HBase and HBase storage, it has its own storage. HBase is a database. HDFS is a file system. That is, it is a distributed file system. HBase data, okay, is also is a database, so that it has its own DDL, DML, and query language to query the data from HBase. HDFS files should be loaded into either HBase or okay or Hive in order to give the SQL query features. Okay, from HDFS directly, it is a file system. It can Spark can read the data from HDFS. That is the major difference. It is a database. It is a file system. Okay. Okay, we got a quick power of big data. Okay, good. Thank you. A big data pipeline. Can you please share the video? Okay, sure. So Kafka is usually a data pipeline tool in the backend. Is it? Yes, yes. So it is one of the a tool which is used in the designing the data pipelines. It is used as a data ingestion layer or used as a streaming platform as well. It can be used as a streaming platform, intermediate level stream processing. It can do live data processing. Okay. Yes, definitely. I will share some links. Yes, yes. So there is a data engineering course in which, okay, we are going to talk about all these systems, including the cloud also, either AWS cloud or Azure cloud, and all the big data systems. We take one of the NoSQL databases. We take one of the distributed RDBMS database. We take one of the distributed parallel processing engine like Spark, and then one of the highly scalable data ingestion tool like Kafka, and then on-premise clusters on AWS cluster. We have a data engineering course, so in which we are going to talk about designing the data pipelines using all these technology stacks. Yes, these are all APIs. All these distributed systems are through APIs, distributed APIs only. You will be doing the coding by using those distributed frameworks. That means all APIs. You are going to use APIs. Follow the rules provided by those APIs to do the coding. That is how it is different from your traditional technologies. Okay, coding. Okay. Thank you, guys. Thanks, everyone. Okay. Yeah. Yeah. BI tools can be accessed directly from the big data systems as well, like Cassandra, directly from Hive, from HBase. Okay. Through some kind of connectors. The BI tools, the latest versions of okay, BI tools comes with okay these connectors, big data connectors. Using that, you should be able to okay access the data from the big data systems. Data analytics also covered in big data. Yes, data analytics will be covered in the big data course. Yes. Yeah. Yeah. Either MongoDB or Cassandra or HBase will take as one of the NoSQL databases. Okay. Yeah, sure. Definitely. will have a contact with skill up, right? So that they will cater your needs. So that Kafka is always, you cannot compare any other data ingestion tools for live data staging or batch processing or live data processing. Kafka is the best when you are using as a data ingestions. Kafka is the best at this point for streaming workloads as well as data ingestion workloads, with which has highly scalability, availability, reliability, and then with very, very high throughputs. Any more questions? Any more questions? Thank you, thank you, thank you, everyone. Okay, guys, thank you so much. It's my privilege to give this overview. Yeah, Databricks is also one of the framework which is very widely used. And you can use Google Cloud Databricks or Azure Databricks or and AWS Databricks environments. They have their own products. So which is internally your Spark programs are running. It is a Spark programs running framework which is very widely used right now. Databricks. Yes, Spark ML is a machine learning library provided by Spark Engine to process very, very bigger data to run your machine learning algorithms related to clustering, collaborative filtering, and then regression, classification related algorithms, the algorithms related to supervised learning, unsupervised learning, and reinforced learning. You are on very, very bigger data, how to run those algorithms, give the results, recommendations, and predictions in a very, very faster way. That's what the ML module is about. Spark ML module is about. Yeah, Skill Upright will share you this record. They are recording this session. They will share you. Contact Skill Upright for this recording so that you will get it. Okay. You got the link from some of the team members from Skill Upright. So you can contact with them so that they will provide you this recording. Yes, you can leave. We are done with the session. It is a 1 hour session.